So this is my AnimationConverter demo. If I start in the AnimationConverter, this is where I'll be converting the teddy bear skeleton and the humanoid skeleton. So I basically start this out. I began this project with a clean import scene file. So I did not use the model converter that we had before for the class, and I basically created a struct that I can write out for each of the bones for the skeleton. And each of them has the associated index, the parent index, and the bone name. And then I basically just have a global array of the bones that gets written out for each of the, depending on the skeleton, each of the skeletons. So this one's for the teddy, gets written to teddy skeleton, and the humanoid. I do have these macros that are found throughout the code just so I could hard switch it. And so the skeleton hierarchy actually gets written out in the display hierarchy file. So they have different indexes because there's random waste junk nodes in the beginning, and there's a different number for each of these, so I had to set those individually. So I basically just began this by printing out the, just want to make sure, yeah. So for the teddy, I just began printing out the association between the bone and the parent, just so I can make sure that the indexes were correctly matching. And so once I knew that I can do this, I just wrote out each of those into the bone array and set the parent and the set the index, the parent, and the name, and then write those all out. So I do that for the teddy and the humanoid. And then for the actual animation data, I essentially went through each animation stack, and I write out a different bin for each of those. So again, with this macro, I have the teddy walk and the teddy idle animations. And then if it's the humanoid, because there's the 3 associated animations for that, I just hard code it in. If the total frame count for this animation stack is 30, because I knew that there was 30 frames for the run, and I knew it'll write that one out. And then same for the punch and the humanoid shot animation. So I then take those and then write those all out. The strange thing was I noticed that for the teddy animation, if the teddy needed the scale and translation and rotation to be set to 0 and 1, but with the humanoid, it actually wants the scale that's found from the model itself. That was a weird issue that I had, where I had to just hard set all of the values for the teddy for one, and then actually take the scales for the humanoid as they came. So if I go ahead and just build this, and this is set in teddy mode, so that's the one caveat, is I have to build these per each type of bone. I need to have some better way of going about that, but for now, I can just rebuild, and we can actually convert these models. So once I know these succeed, and again, I have the vodka and the lick it up as individual projects that get written out as well. So you'll see these EXEs get spit out in here. And so once I know this is done, I'm going to remove any bins in here just so I have a clean start. Looks good. Alright, so if I start the teddy, this will create the skeleton and the animation bins and convert those and package them all into the SPU files. So you'll see these all spit out. The walk, the idle, and then it will create the SPU and then remove these temporaries. So now I could take this, and then if I copy this into my engine for the moment, we'll come back to that. So copy this in, replace the one that was existing just to make sure it works. Then this is the annoying part, is that I actually have hard coded in here the different modes depending on the skeleton, so I just have to change the macro to humanoid. Save and rebuild. And then once this is good, I can start to convert the humanoid. So again, this will spit out the skeleton and the 3 associated animations with the humanoid skeleton, which then I can copy into the engine, and then I could load up those animations from there. This one sure went a lot quicker on my desktop PC. It's going pretty slow. I gotta turn off a lot of these prints, because really I'm printing a lot of data that I don't need to be printing. That's just slowing down the process, but for the sake of time I will leave it in there for now. So again, once these the SPU file is written, the bins will just be erased. Okay, so now we have the humanoid. So now we can close all of this, paste the humanoid into the engine, and now we can run the engine. So in terms of retrieving the data, I basically just take the skeleton and I load that into the PCS tree. I'll start out by showing where I do this and load content in the engine. So I basically just create a new skeleton pointer. And so again, based on the humanoid or the teddy, I'll grab the associated skeleton and create it. And then I have the ability to add multiple clips to the one skeleton. So I basically take in the walking and the idle for the bear. So if I go into where I create the skeleton, I essentially create one, I load up the pyramid model that we're using for the bone, create the graphics object, and set up everything that'll be used in the loop. And then I start this out again with the null, basically the root node, that's the rigid node, and then the animation nodes below it. I create a blank node for the teddy specifically, and then I basically put it in the loop. So depending on which mode this is in, again I have it hard coded as a macro, the number of bones changes. So throughout the code I didn't have to keep doing if statements everywhere, so I just have num bones, and then it'll basically loop through and write those out and add them to the PCS tree depending on its index and its parent index. And then the same for the humanoid. And then in the animations, when I create the clip over here, so if I go to create clip, I eat the chunk and I basically get the number of frames from that. And then so once I have the number of frames, I go into the array of bones that I have, and I have a frame for each of the number of frames, and the frame has a bone array of all of the bones, and then I just write in all of that information. So if I go now, and we're now in the teddy bear mode, I will go ahead and just play this. I have the ability to speed up time, slow down time, pause, and also swap between the different animations per skeleton. So I basically set up 2 cameras because the objects are located in the 2 skeletons, are located in different areas of the world space. So I just have one camera that looks at the teddy bear and one camera that looks at the skeleton. I could show you that in a moment. Need to build all of my files. Okay. So right now we are using the wrong camera. So there we go. So we have this. I could zoom in and out. This is the walking for the teddy bear skeleton. And I could swap between that and its idle pose. You can see that I could swap these on the fly. I have the ability to pause the animation and resume, or I can slow it down, start to reverse it. The same, speed it up and go the other direction, go back forward again. And again, this will translate through both of the clips. And then resume that. So now the humanoid, I just have to go into my macro and switch that out. And it'll read in the other file. And then now the first camera should be in the correct position because I set that up to look at the humanoid. And once we load this, so I basically have the running animation, punching animation, and the shot animation. I could swap between these back and forth. Same thing, I could pause it, resume, rewind it, keep it going in, rewind, and switch between these. That's that. So I definitely need to refactor this because I want to be able to create a multiple animation controllers, because right now I have the animation controller set up as a singleton with only one skeleton associated to it. So over spring break I'll probably split those into different objects so that I can have them each contain their own time separately. So the humanoid skeleton can be running on one time and the teddy bear can run on another. But for now I was able to get this up and running, so I am very pleased. So trying to think if there's anything else I have. I think that's it.